components in Flume's architecture. We'll start with the source, which receives events from any external actor that generates them. The sink sends an event to its destination and stores the data into centralized stores such as HDFS, HBase, and many others. The channel is important in that it will buffer events from the source until they can be drained by the sink, and therefore acts as a bridge between the source and the sink. And the agent is a Java process that configures and hosts the source, the channel, and the sink. We'll learn more about each of these components later on. There are many different types of Flume sources, and they include things like netcat, which listens on a given port and turns each line of text into an event. Apache Kafka receives events as messages from a Kafka topic. And syslog captures messages from Unix syslog daemons over the network. SpoolDoer ingests data by placing files to be ingested into a spooling directory or a commonly shared area on a disk drive. Let's look at the Flume sinks. We've got three here. One is Null, which discards all events it receives. It is the Flume equivalent of the Linux/dev/null target. HDFS writes the event to a file in the specified directory within HDFS, and HBase sync stores the events in HBase. The Flume channels are important in buffering the input speed to the output speed, and includes the memory, which can store events in the machine's RAM and is extremely fast, but not as reliable as the memory itself is volatile. File. This will store events on the machine's local disk, and is slower than RAM, but more reliable as data is written to disk. And the Java Database Connectivity, or JDBC. It stores events in a database table, and is slower than a file channel. Let's look at the Flume agent configuration file. All Flume agents can be configured within a single Java file. In the case shown, the screen, the source, the sink, and channel are all defined as mySource, mySync, and myChannel. You can also set properties of both the source and the sink.